Good morning, everyone. Let us start our lesson today. Today we go to the lesson 14. This is how to prove the trigonometric identities using the double angle formula. Okay, we have learned about 1, 2, 3, 4, 5, 6, 7, 8, 9 formulas before this, which is the basic identities, additions formulas, and also the double angle formula. Okay, so let's look at the example given in your textbook, example 25. Okay, prove. Okay, we're going to prove. Prove, it means that you need to prove from left-hand side or left-hand side to right-hand side or right-hand side to left-hand side. So from these questions, it's involving the formula. You see this one, 2a, 2a means 2a and a, the angles with double. So double, so it means that we need to involving the doubles angle formula, either sine or cos or tangent to a, either one. So we will need to prove from left hand side because the double angle is at the left hand side. Okay, so cosec 2a. So because sine cos tangents only have the double angles formula, right? Cosec didn't have. Cosec don't have, so we need to change cosec into the second first. Second first, change the reciprocal. 1 over sine 2a. Okay, 1 over sine 2a. Then after this, sine 2a. Okay, we're using the double angle formula for sine 2a. Sine 2a is 2 sine a cos a. So 1 over 2 sine a cos a. Then what we want to do, we want to change into this form, right? 1 over 2 second a cosec a. So this one means what? This one means 1 over 2. We can separate it out. So 1 over sine A, 1 over cos A. Okay, so from here, 1 over 2, reciprocal for sine A is cosec A, right? Cosec A. And reciprocal for cos A is second A. So after this, we change the sequence again. So the answer is 1 over 2 second A cosec A. So we prove it already. We prove from left hand side to right hand side. Okay, it's easy, right? So now I go to the B. Okay, B, how we going to know whether it's involving in we need to use the basic identities or addition formula or double angle formula to solve the question, to prove the question, to prove the equation. You see, that's the angles involving double angle. Got double or not? Yes. Cos 2 theta. Cos 2 theta. So it's involving the double angles for cos. Okay, so from here, you need to prove from left hand side or you need to prove from right hand side for this question. We prove from the side with double angle. With double angle. So we have to prove from right hand side to left hand side. It will be easier. This one is more complicated. We need to prove from the complicated side to the easier side. Okay, so for proving, we're starting from the right hand side. Cos 2 theta over cos theta plus sine theta equal to what? Okay, cos 2 theta. We change it up. Cos 2 theta, which one will be suitable for you, do you think? Cosing the first, second, or third? cos and sine together, or the cos only, or the sine only? Do you think which one is more suitable for this question? See your answer. Your answer letter will be in the cos theta and sin theta form, right? So both cos and sine, we choose the first equation. Okay, we choose the first equation, huh? So cos 2 theta, we choose the first equation. So the first equation now is change it into cos square theta. Huh? Don't write a, because here is 2 theta. So it's cos square theta minus sine square theta over cos theta plus sine theta. Okay, continue. How to continue? We want to get the answer in cos theta minus sine theta only. But this one is with denominator or with the bottom in the fraction form. But this one without, the answer is without fraction. But now your step is with fraction form. Then how we're going to do? We need to do is we have to think how we're going to make the bottom part become 1. How to make it become 1? We cannot use divide. You see this question, we always use if the bottom is a plus b. To try, we have to think about other way. This is we have to use 1 minus b over 1 minus b, so that the bottom here will become a squared plus ba minus ab minus b squared. Then this one will become 0. So your answer will be a squared minus b squared normally. So you see this. Why we want to do this? Because we want to do this form. So we have to do cos theta minus sine theta. Same with the concept for the subform. Okay, we do this so that then the bottom part now will become cos theta multiplied with cos theta will be cos squared theta. Then plus minus, so the center one no more already. Then minus sine square theta. This is the bottom part. Then the upper part is how? The upper part is we copy down only cos square theta minus sine square theta. Why? You don't expand up first. We just copy down first. Then after this, you see this cos square minus sine square. Then the bottom also cos square minus sine square. So we can simplify, become 1. Okay, so now your left, your answer is cos theta minus sine theta. So proof already because our answer is cos theta minus sine theta, right? Okay, so we proof already. Now we see a few more extra examples. Okay, prove the following trigonometric identities. Okay, the A, we have to prove cosec 2x plus cot 2x equal to cot tangent x. Okay, how we know? It's involving the double angle triangle. See, double angle. This is the double angle, so we have to prove from left hand side to right hand side. Okay, our final answer, you have to prove until your answer is equal to cotangent x. Cotangent x is 1 over tangent x. Okay, then we're starting from the left hand side now. Cosec 2x plus cotangent 2x. Okay, before we're using the double angle formula, we have to change the cosec and cotangent to the sine or cos or tangent first. Okay, so cosec is 1 over sine 2x, the reciprocal. Okay, then cotangent is 1 over tangent 2x. Okay, what is the relation between tangent and sine? You don't substitute the formula inside first. We study first. You see, can we simplify this expression first or not? Tangent and sine. You need to remember, we always use this. Tangent equal to sine over cos, the relations. Once you see, and one is sine, another is tangent. So what you need to do is you need to change tangent into sine over cos. So from here, this part, you change the tangent to x into sine to x over cos to x. Okay, so it's 1 over sine to s plus 1 over tangent to s. 1 over tangent is equal to what? The balance, right? 1 over, so equal to cos over sine. Okay, so it's equal to cos 2x over sine 2x. Cos 2s over sine 2s. So now you see the bottom part are the same, Same now, is sine 2x. So next, 1 plus cos 2x over sine 2x. Okay, after this, cos 2x, sine 2x, then what is the next step? So we focus on one plus cos 2x. After this, what we need to do? Anything I do wrong? One plus cos 2x, 2 sine x cos x. Okay, never mind, we do it one by one, The bottom part. Now we do the bottom part first. Sine 2x. So now we can start, because we want to change into the cotangent x form, right? But this is the double angles, right? So we need to use the double angle formula now. Sine 2x equal to 2 sine a cos a. So sine 2s equal to 2 sine s cos x. Okay, so the upper part, let it first. 1 plus cos 2x. Then this one is 2 sine s cos x. Okay, 2 sine s cos x. Here, we change using the double angle formula. Then after this, 1 plus cos 2x. So now we need to do the part for 2x. Cos 2x. Oh, cannot see. Cos 2x. Okay, we need to do for this part. Now, cos 2x. Which one? Cos 2x, we have 3 formula. Which one suitable for this question? We don't use the first one. Then we can choose either the second or third. The simplest is second. Why? Because so that yes, correct. The answer is the second one. But why? Why we don't choose the third one? Because of the negative one. Why we want to choose it? Because we can substitute it so that it will become 1 plus 2 cos square a minus 1. 1 minus 1 will become 0. So that it can be simplified. If we choose the third one, it will become 1 plus 1. It's getting 2. It will be more complicated than the second formula. So you see which one will be more simple. So the second one will be more simple. So we change it. The cos 2x. So cos 2x, we choose the third one. So it becomes 2 cos square x minus 1 over 2 sine x cos x. Okay, 1 plus 2 cos square x minus 1. 1 minus 1 will become 0. 1 minus 1 plus 2 cos square x. This one will become 0 over 2 sine x cos x. Okay, so now you left 2 cos square x is 2 cos x, right? 2 kali, 2 times. Then 2 sine x cos x. After this, you see, you can simplify 2 become 1 and simplify cos x become 1. So your answer is cos x over sine x. Cos x over sine x is cos x over sine x is 1 over tangent x, right? So it's equal to cotangent x. So this is your answer. So you prove it already. Okay. B. B. This question more complicated, but this is a very good question. Okay, question B. Sine 3 theta equal to 3 sine theta minus 4 sine square theta. So we need to prove from left hand side to right hand side or right hand side to left hand side. We have to prove from left or right. We have to prove from the side with double or triple or half angle formula with angle. So you see this one is with triple angle, right? Triple angle. Triple angle. So we have to start from left hand side. We start from left hand side. So 3 theta equal to what? We need to change it into the addition form. You see this? I show you all the formulas given. This is all the formula given that you see which one is suitable. Sine 3 theta. So the first we have to, because our double angles is involving with 2 theta only, right? Double, but now it's 3 theta, cannot. So we have to do the addition formula. We have to use addition formula. 3 theta equal to 2 theta plus theta. Okay, so sine 3 theta equal to sine in bracket 2 theta plus theta. So then we can derive it. So now theta plus 2 theta plus theta. So this one A become 2 theta, B is theta, A 2 theta, B is theta. Plus, here also plus, plus. So sine 2 theta plus theta, it becomes sine 2 theta cos theta plus cos 2 theta sine theta. Okay, so now sine 2 theta is the double angle, right? Sine 2 theta double angle. We have to change it. Sine 2 theta by using the double angle formula. Okay, sine 2 theta, it will become what? 2 sine theta cos theta. So equal to 2 sine theta cos theta, and don't forget itself have another cos theta. Another cos theta is here. Don't forget this one. Then plus cos 2 theta. Okay, now the question, you need to use which one? Cos 2 theta again. We come back to the cos 2 theta again. First, second, or third. First, of course, not suitable. We want the single one. Single cos or single sine. We don't want cos and sine together. So you have to look at the back. The back is sine, right? We want to make it the same. So we choose the one with the same, with the sine. Okay, so we choose third one. It will be easier. Okay, so cos 2 theta, we choose the third one. We choose 1 minus 2 sine square A. So we choose 1 minus 2 sine square theta and sine theta. Why? So that sine lah. Then your answer, you see your answer is sine power of 3, right? Sine cube. So sine square multiply with sine, it will become sine cube. Also, you have to be smart to choose the correct formula lah. Okay, so after this, we can get it 2 sine theta cos square theta plus, okay, we multiply in plus what? Plus sine theta minus 2 sine power of 3 or sine cube theta. So after this, cos square theta again. Your answer have no cos square theta, right? So we have to do something for cos square theta. Cos square theta, we need to change it again. Then you go back to your formula list again. You see which one involving the cos square. Of course, we don't use the double angle now because your answer is without the double angle. So we don't look at this one. We don't look at this one. We go to the up. This one. Okay, cos square theta. We change it into 1 minus sine square A. This one you know, Why? Because we want to change all the trigonometry become the sine, become the sine theta, So we choose the third one, sine square theta plus cos square theta equal to 1. So what is your cos square theta? Equal to 1 sine. Move to the right hand side, become minus 1 minus sine square theta. Okay, so we change it up. Cos square theta, 2 sine theta, 1 minus sine square theta. Okay, this one copy down. Sine theta minus 2 sine cube theta. So multiplying 2 sine theta, positive negative minus 2 sine square 3, plus sine theta minus 2 sine cube theta. Okay, so same 2 sine theta and sine theta. So another one, you see, with the same, we add up or minus. So 2 plus 1, 3 sine theta, negative 2, negative 4 sine cube theta. So negative 4 sine cube theta, and this one is 3 sine theta. Okay, so we prove. Okay. Okay, this is the first part. Today we have 2 parts. So this is the first part. Then the homework is lesson 14. This is the homework. Later you do it. Then we go to the another part for the lesson today. This is the trigonometry function applications. Almost done for our topic already, but now it's more focusing on the how to apply in the more to the problem solving questions or the applications. Okay, and now we go to this question. Actually, I discussed these questions already. Never mind, we do it again. Okay, we have the same pattern questions before. Never mind, we drill again. Okay, we look at the example 27. Solve the following equations for the, you see, it gives you the angles. The angle is in the degree form. Okay, we like it in the degree form. You watch out for the question. Sometimes the question will ask you to, will give you the range in the radian form. Then you have to change into the radian form. So this is the degree form. Okay, so what is the first step for this question? is we don't look when you press, you need to find the basic angle first. Sine theta equal to negative 0.5446. So the first step is we need to find the basic angle. What is your basic angle? Is you need to press shift sign what? Shift sign, don't press negative. Don't press negative. Negative is we were using letter to determine in which quadrant, So we use shift sign 0.5446, Shift sign 0.5446. So you get your basic angles is 33 degree. 33 degree is your basic angle. So the negative, second step, we look at the negative now, Negative now, okay. So negative, you will determine the sign will be in the negative, which one will have sign in negative quadrant. Okay, all students take calculus, all positive, sign positive, but we want negative, right? Third and fourth. So negative means the angle will be in third and fourth quadrant. There you see the angle in between 0 to 360. Third and fourth. Two quadrant. The answer will have two. Third and fourth quadrant. Then we do revisions. For the first quadrant. The first quadrant, the angles, let's say is 33. Is 33. Then the second quadrant, how to find the angle is 180 minus 33, right? Third quadrant, 180 plus 33. Okay, then the fourth quadrant is 360 minus 33. This one can remember or not? 33, 180 minus, 180 plus, and 360 minus. Okay, can remember, So now we have the third and fourth quadrant. So your angles, what is your angle? Theta. This is the angle. If here is 2x, then your answer will be 2x. If here is 1 over 2 theta, then your answer will be 1 over 2 theta. Follow the one in the question. Okay, so now theta equal to the answer, the angle in third and fourth quadrant. Third is what? The third is 180 minus 33 degree, and the fourth quadrant 360 minus 33 degree. So your angle is equal to 213 degree and 327 degree. This is the simple questions. The easier question. Okay. Then now we go to the part B. You see this. This one means what? 2 theta. You don't use the double angle. You jangan pandai-pandai use the double angle formula, then change it into the single angle, then do a lot or macam-macam wasting of your time. The way is same with the question just now. This question is very simple. You see this, if the question, it gives you the value for the range for the angles, and also give you the value for cosine or theta. It gives you the value already. What you need to do is you use the shift cos or shift sine or shift tangent to find the basic angle. Then you determine in which quadrant, positive, which quadrant, negative, which quadrant. Then you find the value. That's it. Then another one, 2 theta mean what? 2 theta mean we double up 0 multiplied by 2, multiply by 2, multiply by 2, 2 still 0 360, 720. So 360 is one cycle, right? So 720 means it will have 2 cycles, 2 cycles. So it will have 1, 2, 3, 4, 5, 6, 7, 8 quadrant. It involving 2 times. One time, 1 circle, 2 circle. Okay, 2 times. This is the meaning. 2 theta means 2 cycle. 3 theta, 3 cycle. Half theta, half cycle only. Then you watch out the angles, the range for the angles is given. Okay, so now what is our first step is we find the basic angle. What is your basic angle? Shift cos 0.3420. Okay, so you get your answer is what? 70 degree, right? You get your answer is 70 degree. Okay, 70 degree. So after this, we determine it will be in which quadrant? 70. This is positive, right? You see any negative symbol here? No, it's positive. Okay, we want the cos positive. So we want cos positive. All students take calculus. Cos positive. Of course, the fourth quadrant positive kan? Cos positive and all positive. First and the fourth quadrant. The answer will be located in first and fourth. And don't forget, it's 2 cycles, right? So another one is first quadrant plus 360. Another one is fourth quadrant plus 360. So you will have 1, 2, 3, 4. You will have 4 angles. Okay? Understand, right? 4, You remember? You know, because it have two cycles, so it's double 360 again, plus the first one plus 360, then the fourth one plus 360. Okay, so your angle now, your angle is 2 theta. You don't write theta only, because your answer is 2 theta. So you write 2 theta equal to what? 2 theta equal to the first quadrant. Okay, what is the answer for your first quadrant? So 70 degree. Okay, then another one is the fourth quadrant. Fourth quadrant is what? Fourth quadrant is 360 minus 70. 360 minus 70 degree. So it will become 70 degree and 290 degree. But this is not the answer. Then we still have the third and the fourth, right? The third one is the first quadrant plus 360. First quadrant plus 360, so is 70 plus 360. Answer is 430. Okay. Another one is the fourth quadrant plus 360. Fourth quadrant is 290 plus 360, so answer is 650. Okay, then this is not the final answer yet. The final answer is theta. Theta means this one 70 degree divided by 2, over 1 theta only. So every angle here have to divide by 2 Every angle here divide by 2. So your final answer, theta is 35, 145, 215, and 325 degree. That's it. Okay, can follow? Okay, we continue. Example 28. Solve the equations for 3 sines in bracket a plus pi over 3 equal to 0.99. You see this, it gives you the value. So it means that it's involving the same patterns like just now, but it's more complicated a bit. Then it gives you the range for the angles. The range for the angle is 0 to pi. 0 to pi. 0, pi, 2 pi. So it's 180, 0 to 180. So involving in the first and second quadrant only, right? So it involve in the first or second quadrant only. So it don't involve the third and fourth quadrant. So now another one is the angles here is a plus. This is the angle is 1, right? A plus pi over 3. So here you need 0 plus pi over 3. A plus pi over 3. Pi plus pi over 3. So your angle, the angle you want will be in between pi over 3 and is what 4/3 pi. Okay, it will be in between. Then 4/3 pi, first quadrant. 4/3 pi, 4/3 pi will be 1.5 more. But once you determine out, it will be in the second quadrant. So it will be first and second quadrant. So now we solve it one by one. 3 sine a plus pi over 3 equal to 0.99. Or you don't shift sine 0.99 first. Don't shift sine 0.99. But you move 3 to the back. Okay? You move 3 to the back. 3 move the back, multiply will become divide. So sine 0.99 divided by 3 equal to 0.99 divided by 3 will equal to 0.33. Okay, 0.33. Then you only here you only use because it's sine angle, sine angle. We don't have other things already, So now you only use the shift sign. Use calculator to press shift sign, then you get the basic angle. Basic angle for 0.33 is 0. The angles, we have to change the angle into the radian form. Remember the questions want you to change it into the radian form. So you have two methods. The first method is you straightforward change your calculator from the degree into the radian form first. You do the setting first. Or the another way is you press shift sine 0.33. So you get the answer in the degree form, right? 19.26 x7, right? Degree, 19.26 x at degree lah, and something lah. Then you don't round off your angles. You straightforward press your calculator, answer, multiply. Okay, how to change the angles in the degree form to the radian form. Degree to radian smaller, right? So it's pi over 1 at t. Multiply with pi over 1 at t. So this one, you straightforward, you press your calculator, answer times pi over 1 at t degree. Answer times pi over 1 at t. So get your answer is 0.3363 radian. Radian. This is what we want. 0.3363 radian. Okay, 0.3363 radian. The answer will be in radian form because the questions here, you see the range is given is in the pi. Pi means in radian form. Okay, so you get the basic angle 0.3363. Then determine which quadrant is positive. Positive for science, first and second, all student, all sine. Okay, first and second quadrant. So your answer will be in first and second quadrant. What? A plus pi over 3 equal to, why? Because the angle. This is the angle, A plus pi over 3, A plus pi over 3, first and second quadrant. First quadrant, 0.3363. Okay, then the second quadrant is no more 1 at t minus 0.3363. Second quadrant is 1 at t. 1 at t is pi. Change to radian. So it's pi minus 0.3363. Okay, so it's equal to 0.3363. A plus pi over 3, equal to 0.3363, and pi minus 0.3363 is, press your calculator. $2.8053. Okay, but this is not the final because the final answer is find A. So A equal to 0.3363 minus pi over 3, then 2.8053 minus pi over 3. So final answer for A is negative 0.7109 and 1.7581 radian. Is it the final answer? You watch out this one. This one acceptable or not? Can or not? A. Why? Why cannot? Why we decline this one? Reject. Why we reject or we decline? Because for sine, you have learned about the graph for the sines already, right? The graph for the sine is always in between. The maximum is 1 and the negative is negative. Is in between 1 and 0, right? This one's a negative one, we don't count, huh? The sine, the value for sine is, how to say, it will always in positive and in between 1 and 0. Because the value for A, for sine, it will be in between 0 and 1. Not 1. It's more than 1. Huh? How to explain? It's decline. If you try using the calculator to press shift sign, negative point. Radian. This is the radian. The angles in radian. If you change it into the angles, negative 0.7109, okay, negative 0.7109 change into the degree will become 180 over pi. The angle will be 40 degrees something. The angle will be 40 degrees something. Why it decline? Later I show you again. So we continue. We don't waste our time first. We hold on first. The answer will be this one. Then now we go to the example 29, 28, 29. Look at your textbook. Oh yeah. This is not. This one. Why we decline this one? Why we decline? Because the questions. Sorry, because of the question. The question say it is in between 0 to pi. Pi is 3.142, so decline. We decline because the 0 is in between. The A is in between 0 and 3.149. So this is negative. So we reject it. So your answer is A equal to 1.7581 radian only. So we have one answer only. Okay, then we continue. We continue to example 29 now. Example 29. Find the values of x. So that the range is from 0 to 360. 360 means one cycle involving 4 quadrants. Okay, the first one, sine 2x plus cos x. Okay, now you see this 2x and x. So this is the angles, for the range for the angles in degree form. So what you need to do, you need to change first off. We cannot have double angle and one angle together. But if the question is sine 2x equal to 0, then you can stroke forward, you will find the basic angle. But now it's involving the double angle and single angle. So you have to change the double into the single angle forms. Angle first. So what is your sine 2x? So we have to use the formula sine 2x equal to 2 sine x cos x. Okay, so we change it. 2 sine x cos x plus cos x equal to 0. Okay, cos x the same, right? So we can factorize it out. Okay, this is multiply 1, so cos x. So now you take out the cos x. The first term you still left 2 sine x. Second term 1, 1, not 0, 1 multiply cos x equal to 0. Okay, so now 1, 2. So you get two equations. The first one is cos x equal to 0. Second one is 2 sine x equal 2 sine x plus 1 equal to 0. So look at the first one. Cos x equal to 0 means what? This one, you can use the unit circle to solve the question. Unit circle 0, 90 degree, 180 degree, 270 degree. So cos x is for the x coordinate or y coordinate. Cos x is x coordinate, right? X coordinate, This one, sin x is y coordinate, remember, Cos x is x coordinate. So in which angle the x coordinate will be 0? The x will be 0 here, this one. So you will get 0, 1, and another one is 0, negative 1. So cos x. So cos x will be 0 at 90 degree and 270 degree. This is the first one. 90 and 270 degree. Okay, for cos x. Then now we go to the second one. 2 sine x plus 1 equal to 0. Okay. So your sine x equal to, move to the right hand side, negative equal to, okay, we'll move on. So 2 sine x equal to negative 1. Sine x equal to negative 1 over 2 or negative 0.5. Okay, negative 0.5. So you have to use shift signs 0.5. Use the shift sign 0.5 to find the basic angle. Okay, so the basic angle will be 30 degree, right? 30 degree. The basic angle is 30 degrees. So what is your value for x? Negative. Negative. Negative 1 over 2. Sine will be negative in which quadrant? 1 or 2 or 3 or 4? All students take calculus. So sine will be negative at third and fourth quadrant. So x equal to third quadrant. Third quadrant is 180 plus 30 degree. Then the fourth quadrant is 360 minus 30 degree. So x equal to 210 and 330. Okay, so your final answer is, you have to combine. So we have 4 values, 4 angles. S equal from the smallest to the biggest angle. 90 degree, 210, 270, and 330 degree. That's it. Then B. Okay, can follow? Okay, we discussed 3 more examples. The second one, this one. How to solve this question? Solving questions means find the value for x. Then the value for x is maybe more than 1 value. Depends on the quadrant. It depends on which quadrant is located. Okay, so now you see the angle for involving the double and single angle again, right? 2x and x. So what we need to do is we have to change cos 2x into the single angle form. Okay, cos 2x. Which one more suitable? This one is sin x, right? So you have to change the 2x into cos into sine. Which one is suitable? Cos and sine together, not suitable. Cos, not suitable. We want sines only. So we choose the third equation. So 2 in bracket 1 minus 2 sine square x. Not a, we change this one into x. Okay, x minus 13 sine x plus 10 equal to 0. So multiplying 2 minus 4 sine square x minus 13 sine x plus 10 equal to 0. Okay, minus 4 sine square x minus 13 sine x, 2 plus 10 plus 12 equal to 0. So after this, you don't factorize first. You see sine square, this is negative, right? You change it into the positive first. How are we going to change it? We change the symbol line. Multiply minus 1, multiply minus 1, multiply minus 1. Okay, everything you multiply minus 1. So that positive become negative, negative become positive. So it becomes 4 sine square x, okay, plus 13 sine x minus 12 equal to 0. Then another thing I want to remind you is the student. For example, if the question in 4x squared plus 2x plus 6 equal to 0, then you don't simply do the factorization first. No, you don't do this step first. You need to simplify the equation to the lower form first. So you see that 4, 2, and 6, they have same factor, right? So you have divide by 2, divide by 2, divide by 2 first. Okay, divide by 2 so that you get 2x squared plus x plus 3 equal to 0. This is the simplest form. Okay, then you only start to do the factorizations, okay? So from here, 4, 13, 12, we cannot simplify some more. So we can do the factorization. That's why if you cannot do this, you make the sine x become y first. You change it into 4y squared plus 13y minus 12. But if you can straightforward do the factorization. Sine x, then 3, 4, 12. Can use calculator to help you also. Okay, so you get sine x equal to 3 over 4 or sine x equal to negative 4. Then sine x negative 4 we decline. Why? Decline because now you can say the sine x, the value for sine x is in between. The value for sine x decline as the value for sine x. You use your calculator to press, you will know your value will always in between 1 and 0, right? The value for sine x in between 1 and 0. I think it's in between 0 and negative 1. Sorry, the mistake here. Negative 1. Because the graph for the sine will be in this form. So the value for sine x will be 1 or negative 1. In between 1 and negative 1. But your answer here is negative 4. So it declines. We don't accept this one. So we only look at this one. Sine x equal to 3 over 4 is 0.75. So you find out the basic angle first. What is your basic angle for 0.75? Shift sine 0.75, so it's 48.59 degree. And after this, you see positive, positive. So first and second quadrant. First and second quadrant, so X is in the first quadrant, 48.59 degree. Then the second quadrant, 180 minus 48.59 degree. So value for X is 48.59 degree and 131.41 degree. Okay, so I want to discuss two more questions before we end up the lesson today. So give me 10 minutes more. So before we go to the next question, you have to know this one. This one I already discussed for the previous lesson, how we're using the unit, or how we're using the unit circle to find the specific value for sine, cos, tangent for the angle 0, 90, 180, 270, 360, and specific 45 degree, the related for the 45 degree. Okay, so now we look at the example 1. Okay, solve the equations given you the range and given you the angles. Okay, you see this one. S plus 60. S plus 60, so mean that we involving the addition formula. We're involving with the addition formula. Okay, so we have to solve it. This is solving, this is not proving, so you have to solve it. So we solve it one by one. 2 sine x equal to 3. We change the cos, bracket s plus 60, the addition for s plus 60. S plus 60, change it to cos x, cos 60 minus, minus sine x, sine 60. Okay, we change it. Cos x, cos 60 degree minus sine x, sine 60 degree. Okay, now let's say you have no calculator, without calculator. Let's say we have no calculator, then how you're going to find the value for cos 60 and sine 60? 2 sine x equal to 3. Okay, this one we okay, we multiply in first. Okay, minus 3 sine x sine 60. Okay, so now we do the value. We find out the value for cos 60. What is the value for cos 60? Use your left hand trick, use your finger. 0, 30, 45, 60, 90. So 60 is here. Cos 60. Cos is go down or go up? Cos is go up, right? Go up one step. One step is 1. Square root 1 is 1. 1 over 2. And minus 3 sine x, sine 60. 1, 2, 3. 3 step downward. Square root 3 over 2. Okay, then we move it up. 2 sine x equal to 3 over 2 cos x minus 3 multiply with square root 3 over 2 sine x. Then you see sine and sine the same, right? So move this one to the front so that they can be together. The sine can be together. So get 2 plus 3 square root 3 square this one we'll move it together. Sine x equal to 3 over 2 cos x. So after this one change it into the single fraction form first. Change it into the single fraction form. So it's over 1. Multiply 2, multiply 2. So you will get 4 plus 3 square root 3 over 2. Okay. Sine x equal to 3 over 2 cos x. Then after this, how to simplify again? Always remember the relation between sine and cos is what? tangent x equal to sine x over cos x. So we move here. So sine x, move the cos to left hand side. It become multiply, become divide. Sine x over cos x equal to 3 over 2 divide 4 plus 3 square root 3 over 2. Okay, up and down. Or before we move, one step. These two, to one in here. This one we can move to the right hand side, so we can simplify first. So you will get the value is 3 over 4 plus 3 square root 3. Sine over cos is tangent. Tangent. Anything wrong? What did I do wrong? Sorry, I check first. 3 over 2. 3 over 2. 1 over 2 sine square 2x. Two over 3. 3 cos x plus 60. Like this. So you get tangent s equal to 3 over 4 plus 3 square root 3. Okay, then after this, you have to use the okay. Sorry, blank. Okay, after this, we need to find the basic angle for this one. Shift tangent the value, So what is your value? So if you get the value for the tangent s is 3 over 4 plus 3 square root 3. Then we find the shift tangent, So you get the basic angle will be 18.07 degree. 18.07. Then it's positive, so your tangent positive. All students take calculus, tangent positive, first and third quadrant. So answer will be at the first and third quadrant. So x equal to first quadrant 18.07 and the third quadrant 180 plus 18.07 degree. So x is 18.07 degree and 198.07 degree. One more question. Last question. This is the last already. Okay. So almost the same. Cos 2x. We change it. And before we change the cos 2x, we look at the addition first. We look at the addition first. This one, the additions, right? So we have to change 2x 60, 2x 60, 2x 60. Change the signs into the, we take out the additions first. So it will become 2 cos 2x equal to sine 2x cos 60 plus cos 2x sine 60. Okay, we change it first, then we find the value for cos 60 first. Use the finger. Okay, cos 60 will be, make it in the subfront, 1 over 2. Use the left hand trick, same like the question just now. Cos 2x, then the sine 2x is square root 3 over 2. Okay, square root 3 over 2. Then after this, you see cos the same, right? We can move the cos together first. And another thing, do we need to change the double angle into the single angle? No need. You know why no need? Because all the angle here are in double angle. All in double angle, so you no need to change it by using the formula, change it into the single formula again. No need. Okay, so after this, the cos, we made the cos together lah, huh? So 2 cos 2x minus cos 2x, sorry, the square root 3 over 2, we move to the front. So it will become square root 3 over 2 cos 2x equal to sine 1 over 2 sine 2x. 1 over 2 sine 2x. So the same we can move together, factorize. So we move it together. 2 minus square root 3 over 2 cos 2x equal to 1 over 2 sine 2x. Okay, then this one simplify. No, we change it. So it becomes 2 to 4, multiply 2, multiply 2. So 4 minus square root 3 over 2 cos 2x equal to 1 over 2 sine 2x. Okay, then 2 can simplify. So now you get 4 minus square root 3 cos 2x equal to sine 2x. So again, sine 2x over cos 2x. This one, sine and cos can change to tangent. 4 minus square root 3. So tangent 2x equal to 4 minus square root 3. So what is your value for your tangent 2x? You find the basic angle. What is your basic angle? Shift tangent 4 minus square root 3, 66.21 degree. It will be in which quadrant? Positive value. First, all students take calculus. First and third, but your answer will be in 2 cycles. So you will have first, third, then plus 360 plus 360 again. So it means that your answers for 2x will be has 4 value. The first quadrant, third quadrant, and the first plus 360, and the fourth and the third plus 360 degree. You will have 4 angles. Okay, the first one 66.21, second one 180 plus 66.21, and the third one you get 2x is 66.21, and the second one is 246.21. So it's 246.21 plus 360. So another one, sorry, this is the fourth one. You will have 66.21 plus 360, and the last one is 246.21 plus 360. Okay, so you get first, second, and third is 21, and your angle will be have to divide by 2 again, because we need to find the value for x. So your final answer is 33.11 degree, 123.11 degree, 213.11 degree, and the last one is 303.11 degree. Okay, that's it. This is all I want to discuss with you today. Then this is your homework.